finding the correct x value. But the more you do it, the better you'll get. All right, third one. Let's go for it. And remember, you have the original function, and you have the inverse. I kind of like to think about it as these two parallel tracks. If you want to just use the formula, that's fine. Different people like it different ways. I think this way I can remember it a little bit easier than trying to remember 1 over f prime f inverse of a with all sorts of parentheses all over the place. Just remember, this side is going to have its x value, and the original function is going to have a different x value. Yeah, so let's see, the inverse derivative at 2. So I know the inverse side is using 2, and that's really what I want, right? The derivative of the inverse at 2. That's the goal for this question. And here we could figure out the original function instead. Now this one's a little bit unique. It's kind of like the first example we did way back in the pre-cal on the previous page. If this is my original function, right? So let's say my original function is y equals the square root of x plus 1. Could I actually find the inverse? Yeah, like we literally did almost something identical to it a while ago, right? I could switch the x's and the y's, and then I could solve this for y. It would be pretty easy. And if I were to actually solve this for y, that would be g inverse. And if I can find g inverse, then I can manually take its derivative. And if I have the derivative of the inverse, I could plug in 2. So you could kind of brute force this, right? You could find the inverse. Once you find the inverse, you could take the derivative. Once you take the derivative, you could plug in 2. You could do it. I'm still going to do it kind of the other way. Remember, sometimes it's not going to be possible to find the inverse. So you have to flip it over. And instead of doing all the stuff on the side of the inverse, you flip it over, work with the original function, and then you flip it back. Remember, flipping it back at the end, you just have to take the reciprocal. So while you could brute force this example 3, you could find the inverse, take the derivative, and plug in 2. I'm going to still flip it over to the original function and then do it the way that I did on the example previous. So first thing, let's figure out what is the correct x value for this original function. I need to think g of what is going to give me out 2. So I need this function to give you out 2. This is something pretty easy. You don't have to guess and check. This is something that you can solve. Square both sides, then subtract the 1. Here you can see that this x value is going to need to be 3, right? G of 3 would give you out 2. So that means this x value for the original function is no longer a question mark. That x value for the original function would be 3. The inverse is using 2. This original function is using 3. The first thing is figuring out what is the correct and corresponding x value for that original function. Then you need to take the derivative, plug in 3, and then take the reciprocal. That's the relationship between them. All right, let's go for it. G prime, you have 1 over 2 roots of x plus 1. Don't plug in 2, plug in 3. That's the value corresponding to the original and its derivative. Let's see, 3 plus 1 would be 4. Square root of 4 would be 2. 2 times 2 would be 4. So if I were to plug in the original function's derivative, and by plugging in, I mean plug in 3, remember its x value, looks like the original function's derivative is 1/4. So even though I could have manually found the inverse, then I could have taken the derivative, and then I could have plugged in 2 into that derivative. I don't really have to. I know that the derivative of the inverse is going to end up being not 1/4. It's going to end up being 4. If you want, you can check it. Like you can manually find this inverse, switch the x's and the y's, solve it for y, right? You can find the inverse. You could take the derivative. You could plug in 2. It's going to end up being 4. A lot of the times, though, you're going to see examples either like the previous or like the first example on this page where it will not be possible to find the original, to find the inverse function. So you're either going to have to use the weird ugly formula or you're going to have to know what this process is. Remember, the process is the same thing as the formula. All of this stuff, f inverse of a, that's the same thing, finding the x value for the original function. Then you're doing f prime of that stuff. You're taking and evaluating the derivative with that new number, and then 1 over just means take the reciprocal. All right, last one, then we're done. Here's my original function, cosine, says I have a domain restriction, really nice, 0 to pi for the original function. That's really wonderful. It says take the derivative of the inverse at root 3 over 2. So I've got the inverse function, and its x value is root 3 over 2. I have this original function, right? That's the inverse at root 3 over 2, and then you have the original function. Remember, we're going to need to figure out what this correct x value is. Now, is this something like the previous example where I could find the inverse, or is it something like the first two where you could not? Well, you could easily find the inverse. The inverse function is literally cosine inverse, or your arc cosine, and we know how to take the derivative of that. We did it back in the yellow packet, I think it was yellow. We know how to take the derivative of inverse cosine, so I could find the inverse function. I could take the derivative myself. I could plug in this. You could do it that brute force way if you want. I'm gonna still kind of shift it over, and instead of working on the inverse side, I'm going to shift it over to the original function. I'm going to work with the original function, and then I'll just shift it back at the end. So you could brute force it. I'm not going to. All right, first thing though, I need to figure out what is that correct x value. What is that question mark going to be? What's the x value for the original function? So what could I plug in to the original that would give you out root 3 over 2? So cosine of question mark is going to equal root 3 over 2. I know, oh my gosh, trig is so terrible. But here you should know, hopefully, that that's going to end up being pi over 6, right? It's the point right there on your unit circle. Yep, that made it on the camera. That was really good. All right, so the x value for your original function is pi over 6. Remember, you have the inverse with its x value, then you have the original with its different x value. Going to be different, so just be careful. All right, now I need to take the derivative of the original. I'm going to plug in pi over 6. Then I'm going to take the reciprocal 3 more steps. Then we're done. The derivative of cosine is negative sine. And then I need to plug in your pi over 6. Remember the value that we found. You have to find the correct value. Then you take and evaluate with that new value. So I got negative sine pi over 6. Sine of pi over 6 would be 1/2. So I have the negative 1/2. So I know the derivative for the original is negative 1/2. That means if I would have found the inverse, and then if I would have taken the derivative, come on pencil, you can do it, almost done. I know the derivative of the inverse at root 3 over 2, it's not going to be the exact same thing. It's going to be the reciprocal, right? Here was the original derivative, so the inverse derivative would be the reciprocal negative 2. All right, so this stuff with the inverse derivatives, it's a little bit strange, but it's not terribly hard. In fact, it's some of the easier questions you would see on a typical AP exam. It's a weird, ugly formula. Sometimes you may be able to brute force it. You may be able to find the inverse and to take the derivative and to plug it in. That's great. Other times you may not. Sometimes you're going to have limited information. Other times, algebraically, it just may not be possible for you to find the inverse. But that's okay. Instead of working on the inverse side, you switch it over and you work with the original side, right? You got to find that correct x value first. Then you can take and evaluate the derivative of the original with that new x value. And you find the derivative of the original value. And then you just take the reciprocal of it to move back to the inverse. It's a little bit weird. Kind of just remember back to this very first example, right? We have the original and the inverse. The original was all using 2. And then I had the inverse, which was using 8. There was a relationship between the 8 and the 2, right? But the original used its x value to get the derivative. The inverse used its x value to get the derivative, but in order to move from one derivative to the other, right? If I was working on this side, but I really wanted this, you would just have to take the reciprocal at the end. So that formula, a little bit weird. The process, though, isn't too terrible. Find the x value for the original function, take and evaluate the derivative of the original function with that new number, and just take the reciprocal at the end. All right, hopefully that helps. Again, follow the answer key on my website.